Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello and welcome everyone to the talk, Platform Freedom with Micro-frontends. So this talk will take you through a list of micro-frontend strategies, a new framework that was built on top of micro-frontend, and how this new framework helped in building an application that can run on various distributed systems. So before getting into the topic, let me introduce myself. I'm Saravana Balaji Srinivasan. I work as a senior software engineer at Red Hat with the role full stack developer, mainly on JavaScript technologies. I work in the areas where we have built tools for business automation products, serverless workflow specifications, etc. So yeah, that's about me. Getting back to the topic. So this talk I wish to deliver in such a way, like sharing my experience and the learnings we at Red Hat had while implementing micro-frontend strategies for one of our use case. So to start with, maybe let me start with the Red Hat story. So sometime back, we at Red Hat had a certain use case where we had to migrate one of our legacy product called JBPM, which is a business automation product. We had to migrate the product that can accommodate some of the latest technologies, and it must accommodate the future technologies as well. So that's when we were thinking of micro-frontend strategies. We had some sort of learnings out of it, and then we came up with a new framework on top of micro-frontend, which we named it as the multiplying architecture. And this multiplying architecture helped in solving some of the problems that we had, and finally it helped us to achieve the goal that we had. So the upcoming slides will take you through the list of learnings that we had out of the micro-frontend and the new framework. And so yeah, that's the talk is going to be about. So firstly, I would like to break my topic, the platform freedom with micro-frontends, and so on. I would like to emphasize what I mean by the term platform here and the list of platforms that we were targeting for our use case. So we all know that web technology is totally dominating the software development at this point. So whether the developer or the company who wish to build an application for their use case, web technology is considered as their default choice, right? So this is because web technology has stronger foundation, stronger standards, patterns, techniques, architectures, etc. And also, web technologies are rich in ecosystem. So when we speak about ecosystem, we cannot ignore JavaScript. Though it has initially started as a scripting language, now we can find JavaScript everywhere. So over the period of time, it has grown fastly. So that's the power of JavaScript at this point. And after the introduction of TypeScript, people like me who started the career as a backend developer on Java technology started liking TypeScript after learning. Started liking web technology after learning TypeScript because my code is totally type safe, right? And also I could emphasize that browser is everywhere at this point. You can find browser on your laptop machine, mobile, servers, etc. Right? So now browser is just it's not only a tool to access your internet or to access your GUIs. It has become more than that. So when I say browser is everywhere, one can run the web components anywhere, wherever you have the browsers, right? So these are the list of platforms that we were targeting. We wanted our web components to run on Visual Studio Code as an extension and browser as an extension. Say, for example, if you have GitHub, Chrome as a browser, my web component must run as a Chrome extension. And in case of Firefox, it must run as an Firefox extension. And my same set of web components must run on GitHub as well as an extension. And finally, we had web application as an option as well. So the reason for choosing these platforms is that the web components are that we had were tooling components. These tools are going to be used by the developers who are going to build an application out of the business products that we have, and these are going to mainly used by the developers, and developers mostly use these four platforms, right? So that's why we were targeting these main four platforms. So while having this use case in mind, we were thinking about various architecture that were existing, starting from evolutionary architecture and then the microservice, which is a path breaker on the backend world that allows breaking a bigger monolith backend application into a smaller microservices and without being dependent on each service. And then comes the serverless, which is a buzzing word at this point, which is the way called as backend as a service. You don't have to own an entire server. You can just have your backend logics run as a function, and you can just pay for the number of hits that your function gets. So you don't have to own an entire server. So then comes the micro-frontend, which is something that we are going to discuss elaborately in this talk. So I don't want to go and answer the question, what are micro-frontends? You might have answered, you might have gotten enough answers for this question and a lot of talks, right? So you might have seen images like this with tall pillars, and that represents monolith application, blah blah blah, etc. So let me just conclude with the quote by Cam Jackson. A micro-frontend is an architectural style where independently deliverable front-end applications are composed into a greater whole. Simply, the goal of micro-frontend is to decouple your monolith application. So when you have a monolith chunk of application which is tightly coupled and you work with one big vast team, you are obviously bound to a lot of issues, bugs, and addressing all these bugs and issues will be very difficult, and the downtime of a monolith application is also quite high. So definitely this has to be broken down into smaller micro-frontends. So there is an idiom in English where they say, don't put all your eggs in one basket. So definitely this applies for the micro-frontend as well. You don't have to put all your code in one bigger chunk of monolithic application. You can diversify your application. So diversification is just not only applicable for your money. So it also applies for the technology as well. You can diversify your application into smaller micro-frontends, and you can make it independent, and each micro-frontend can be accessed or developed by a separate, more autonomous team. So this diagram will give you an example of how a micro-frontend application looks like. So as I mentioned earlier in my previous slide, I work for a team where we build tools for various products. This is one such tool, which is called as DMN, which handles business law rules, and it represents the business rules in a graphical manner. So considering this view, a header component can be broken down into a separate micro-frontend. You may think that here the header looks very small. Why would that qualifies as a separate micro-frontend? So designing a micro front end or breaking your UI into a smaller micro front end is definitely depends on the organization decision as well, or the team decision as well, whether you definitely want to break that particular component as a micro front end or not. But on the other side, consider if you have an e-commerce kind of an application where header itself may contain a huge chunk of React components, or any framework, right? So starting with your profile section, your logo, company logo, search bar, drop downs and sub drop downs, too many components, right? So this definitely qualifies for a separate micro frontend and could be maintained by a separate team. So coming back to this view here, so as I mentioned, this header could qualify as a separate micro frontend, and the editor at the bottom, which represents the graph, definitely could maintain as a separate micro frontend and could be maintained by a separate team. And there is a navigation bar at the left, could be maintained as a separate micro frontend. All these micro frontends are contained inside one container application, which takes the major decisions. So while speaking about the micro frontend, or speaking about decoupling, micro frontend is not the only option that we have to decouple a monolith application. There are other strategies or techniques as well. So one such is modular monolith, where your frontend could be broken down into smaller UIs and libraries could be shared among this. But still, these UIs are tightly coupled among them, are contained inside one single application. And there is another strategy which is called as integrated application. Though here the application could be the UIs could be broken down into smaller applications and the libraries could be shared between the applications, but this follows a build time composition. And finally, we have the strategy that we are discussing, which is micro frontend, where the application, the UI, the UI pages is broken down into smaller applications, and this micro frontend follows runtime composition. So we will see what this build time composition or runtime composition elaborately in the upcoming slides. So again, this slide will give you an idea how micro frontend looks like and how microservice looks like and how they differ. So the first one shows you how a monolith application looks like. You have your front end, you have your backend, and that backend connected to the data source. The request from the front end passes through the backend, and that backend fetches the data from the data source and passes on to the front end. When it comes to the microservice, your backend is broken down into smaller microservices, and there comes another layer between the front end and microservices, which is called as the gateway API, which takes the decision of routing the request from the front end to the corresponding microservice, which can handle that particular request. After the introduction of micro frontend, the front end application is broken down into smaller pieces, and that communicates to the API, and that API routes your request to the microservice. So we will see another interesting strategy of the micro frontend, which is called as BFF. Yes, you heard me right. Actually, it is not abbreviated as best friend forever, but it is. It is a best friend for the micro frontend. The actual abbreviation for BFF is backend for frontend. So this BFF ensures seamless user interaction between the microservice and the backend. Micro frontend and the backend microservice, irrespective of the platform wherever it is running on. So if you closely look at this diagram, each micro frontend is connected to its own BFF, and that BFF connects to the microservice. So there is no direct communication from the micro frontend to the backend. So all the communication happens via the BFF, and this BFF is responsible of handling the request and response. It also converts a response from the backend and it presents it to the micro frontend in such a way that it can understand. And if you closely look at this diagram, and there is no communication between the micro frontend as well. All the communication between the micro frontends happens only inside the container application only, or the other way you can call it as app shell. So while discussing about the micro frontend strategies, yeah, you have your micro frontends created and you have your teams working on each of your micro frontends. They are independently working, fine, yeah. But all the micro frontends has to be integrated on the container application and it has to be presented to the user, right? So while thinking of integration strategies, there are two main strategies that exist. One is runtime integration. The other one is build time integration. We have seen this names in the one of our previous slides as well. So let me start with this runtime integration. So imagine if a team A building a component C and they deploys it. So that component could be accessed in this URL, the domain name slash the component name.js, because this component is deployed as a bundle. Whenever the user tries to access the website, the container application takes the whole control and it loads the component C and it will decide when this particular component has to be rendered. So this strategy is kind of widely used across the people or developers who implement micro frontend, but it has its own pros and cons. The pro is being um, the teams can deploy their components at any point. I mean, they don't have to depend on other teams. And the downside of this application, integration strategy is the setup time or the setting up this integration strategy is far more complicated. So coming to the next integration strategy that we have, that is build time integration. So in this case, again, considering a scenario where a team A builds a component, so that component is shipped as an NPM package, where with this strategy, this NPM registry comes as a boon for us to contain all our components as a package. So the other team who wants to use that particular component, they can install that particular component as a dependency to their micro frontend, and they can just use it. Again, this looks easy to set up and understand, but the downside of this strategy is every time when you implement, there is a change in the package that you build, the entire application has to be rebuilt again. Or if you want to introduce new dependency or new package or new component, the entire application has to be rebuilt again. So that rebuild time is again quite high. So there were other concerns associated with the micro frontend strategies. One such thing is styling. Imagine if you have various micro frontends. When you apply one particular style for micro frontend, that could override the styles on the other micro frontend as well. When you unify all the micro frontends on one container application, yes, of course, this could be resolved by using iframes, where each micro frontend can be rendered on the browser inside an iframe, so that this iframe totally isolates your micro frontend, so that style changes on one micro frontend will not affect the other one. But there are other concerns with this using of these iframes as well. Being iframes is not something new or something, right? So it's a very age-old approach, and at this point, at this evolution of technology, I feel that nobody will prefer to use iframes. Definitely, developers across would prefer to use or to render the micro frontends just inside a div or any other tags that they wish. So that's when after coming across or thinking about all these concerns that we had across the micro frontend strategies, we were thinking of coming up with a new architecture. So these were the requirements that we were thinking about. We had actually starting with the multiple distributions. So the web components that we have must run on various distributions, like it has to run on VSCode as an extension, GitHub as an extension, browsers as an extension, and finally as a web app. And this has to happen with minimal code changes, and there should be a bridge to the future tech stacks as well. So if, in case if at present I use React framework for my web components, in future if there are some other frameworks, for instance, if I have to use Vue, I must be able to easily change that framework as well. So my micro front-end strategies must accommodate any new technology that I wish to migrate. So that's when we introduce a new framework called the multiplying architecture. So before understanding multiplying architecture, let me understand what is software architecture. So according to Ralph Johnson, a software architecture is about the important stuff, whatever that is. So what is that important stuff? So it is abstraction. So what basically we wanted to abstract our web components and we wanted to present to the various platforms that we have. So abstraction is being considered as the utmost priority for our use case to migrate or to deploy our applications on the platforms that I showed you in the previous slides. So these are the core elements or the core components that we built as part of the multiplying architecture. One as being channel, envelope, view, and the editor. So the channel is being considered as the platforms that we were discussing so far, and view or the obviously the web components that are built on React.js, and envelope is something that communicates. That enables a communication between the channel and view in order to pass data, etc. And editor, the editors that we were discussing. It could be the DMN editors that I showed in the previous slide, or there were other few editors that we were using for our products. So we wanted our editors or the tools to run on the web like this. So if you see, look at this screenshot, the BPMN editor is wrapped inside the envelope instance. That envelope instance is wrapped inside the channel. And the same editor must run, the same set of web components must run on the browser as an extension like this, on the GitHub as an extension like this, and finally VSCode as an extension like this. So this is how the envelope enables the communication between the channel and the view. So if you see here, there is no iframes use. So we are rendering our components of the micro frontends via div instead of iframes. And also these envelope, channel, and editor are contained inside the envelope, view, and editors are contained inside the channel. So the advantage of envelope is the context isolation. So my micro-frontends are totally isolated, and there is a better communication established between the channel and the view, and this creates an autonomous team as well, and each team could have its own release cycles, and this entire multiplying architecture are built on top of TypeScript, so it is totally type safe. So let's see multiplying architecture in practice. So let me take you through the code base that I have. I'll be sharing this URL with you, where you can access these examples. So here I have a folder called examples, which contains a list of micro frontends. These are, I have some basic examples like to-do list, ping pong example, and there's another called base64 to PNG, which converts your image to a PNG. So these are individual micro frontends, and these micro frontends I wanted to run on various platforms. So here let me take the classical example of to-do list. So this is the to-do list view is the micro frontend, and I want this micro frontend to be running on the channel VSCode as an extension. And it has to run inside the web application as well. So here, if you see, there is a folder called, which is again a different micro frontend, and you will see a dedicated page for the to-do list as well. So this web app containing all the examples that I have here, the to-do list, ping pong or base 64, etc. But at this point, we'll just take one example and see how it is implemented. So firstly, we'll start with how this multiplying architecture is implemented. So this multiplying architecture follows a separate, a dedicated folder structure. Let me start with the dependencies, what are that you need to install. So firstly, these are the two packages that you must use. So these are available as part of this key tools core. So at this point, here I'm using I'm not mentioning the version here because it is the core implementation of this envelope is residing on the same repository. So I have used workspace here. But if you're trying this multiplying architecture, you may see the exact release of the version number, the recent release of the version number that you can see on the npm registry. So these two dependencies that you may need, one is envelope and envelope bus. These two enables the communication between the channel and the view. And if you go inside the src folder, you may see three folders, main folders, that is API, embedded, and envelope, starting with API. So this to-do list API, so this contains list of abstracted methods that are exposed to the external world, and channel API file. This file contains a list of abstracted methods which are exposed by the channel and consumed by the envelope. So using these methods, the communication between the channel and the envelope happens. Whatever the message that channel has to communicate to the envelope or happens inside these methods. So here this files contains only the abstracted method, but the definition of these methods are provided inside the channel. We will be seeing that as well. So there is again another file, envelope API, which contains an abstracted method for which are exposed by the envelope and that are consumed by the channel. So there is another folder called embedded. So this is considered as a starting point that triggers the view. And if you see here, you will see a React component embedded to-do list envelope. So you will see what this to-do list, embedded to-do list envelope contains. So it is actually imported from this folder, envelope, which contains envelope, to-do list envelope.tsx, again, which is a React component. Here, this view, to-do list envelope view contains your JSX code for the to-do list application, which contains all the HTML content and the CSS content and the React code, all the use callbacks, use state, etc. Yeah, it is a functional component again. So this view is rendered inside the envelope, and this envelope is called inside the embedded to-do list. So this embedded to-do list envelope will be called inside the channel. So that is something we'll be seeing here. So now let's go to the channel VSCode extension. So to implement, in our case, we had, to render our view, web components on the VS Code. So we were making some sort of configurations for the VS Code extension. So if you are also trying the same, you may have to first learn how to create an extension on the VS Code. So this folder structure, some of the files here deals with the configuration for the VS Code extension. So starting with this extension.ts, which will initiate the extension and so some of its dependencies as well. And if you see this index.ts here, this to-do list envelope, view envelope is initiated here. This will trigger the React components or that we saw in the other micro-frontend, right? So if you see here in the package.json, the micro-frontend is added as the dependency here. So let's take the easier example of web application. Maybe you will get an idea about how this really looks. So again, we'll show you how here this is the micro-frontend is added as a dependency here, installed as a dependency here. And I've created a separate page for to-do list which calls the embedded to-do list, which I showed in my other file. So this is imported from key tools example to-do list view, which was the micro-frontend that we were discussing so far. And this page is called inside the app.tsx, which where I have provided various navigations, because this web app contains other applications as well, examples as well. So I've provided separate navigations for each of the examples that I have here. And all this app is contained. This is the root of my React application. So let me start this application. And see. So yeah, I'm starting this application. So on the localhost 9100. Let's give it a time to load. Yeah. Guess it's coming up now. Yeah. So yeah, as I mentioned, so this web app contains a list of all the examples that I have in this repository. So let me go to this to-do list view that we were discussing. Maybe I'll just create a list Conf42 JavaScript conference 2022. So I created this node. Maybe I can just mark it as complete, or maybe I can unmark it. Also, I can remove it. So just simple example of to-do list. So yeah, this is how it works. So the same set of micro-frontend component or React components were used on the VS Code as an extension, on the web app as an extension as well. So let me jump back to the slide. So far we have seen the the multiplying architecture in practice. So after implementing all this channel, view, envelope, or multiplying architecture, or micro-frontend strategies, blah, blah, all these things, still we were having some sort of issues while integrating all the micro-frontend components into one container application. So these were the issues that we were facing. So the main highlighted issue that we were facing across both the strategies are the duplication of libraries that we're loading. Say, for example, if I have 3 micro-frontends for my application, and each of the micro-frontend has React as a dependency for in its micro-frontend, when I integrate all the micro-frontends, 3 instances of React dependency is created. So if you just think about, it's like duplicating of one dependency, though it is like commonly used across the micro-frontend. 3 instances are created. So imagine if you have more number of dependencies that are kind of duplicately created across the micro-frontends. Either the bundle size or the size of your application will become too high. To overcome this issue, federated modules came to our rescue. So you might have heard about this term, federated modules. This was introduced in the Webpack in its 5th version. So this gave us a solution to share dependencies across the micro-frontends, and this also allowed us to implement the runtime integration as well. So here, this is how the Webpack configuration looks like, implementing the module federation. So initially, the module federation has to be imported from the package, and here on the plugins, you must create an instance for the module federation, which must contain list of routes for the number of micro-frontends that you have, and these routes will be rendered on the browser only when it is called, the particular micro-frontend is called. And if you see here on the line number 23, the dependencies are shared among all these micro-frontends so that there won't be duplicate instance of dependency. Also, on the React side of it. So this is how each micro frontend will be rendered on the view. We are making use of the lazy imports from the React. Um, we are importing the micro frontend only when it is needed, and here we have created routes, and we are just navigating to the respective micro frontend whenever it is called. So finally, after implementing the micro frontend, the multiplying architecture with the micro frontend strategies, along with the federated modules, we were able to achieve these end results that we wanted: the multiple distributions with the minimal code changes, and also we were able to achieve the bridge between the tech stacks. So these were the achievements that we were make out of the multiplying architecture. We were able to implement the microservice architecture, and we were able to take the advantage of runtime integration, and we created the autonomous team. There was no duplication of libraries between the micro frontends, and yeah, we were able to develop a bridge between the tech stacks as well. So you can find the code base that I was showing here in this URL. And in case if you have any questions, please feel free to shoot it out.